Hi everyone, today we're talking about how to test solutions to inequalities and how to graph inequalities. As a reminder, you do not need to write down everything that we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it. But be careful, make sure you don't fast forward too much that you end up missing out on something important. So far we have talked about expressions, which again are math problems with no symbols, kind of like 2x plus 7, with the two terms 2x and 7 being added together. We've talked about equations. Those are problems with equal signs. You would solve them and you would get one answer at the end. And today we are talking about inequalities. Those are math problems with an inequality symbol. So for instance, this one is 2x plus 7 is greater than 49. Greater than is the inequality symbol. So like we said before, equations, when you solve them, you have one answer, one solution. So inequalities, you're going to want to add into your notebook, have more than one solution because you're looking for all the possible values. For instance, in this problem, that'll give you an answer on the left-hand side that's greater than 49. There's tons of numbers that are greater than 49. 50, 51, 52, 53, 54, all the way up until the largest possible number that we have discovered. So inequalities give you more than one answer because there are tons of numbers that could be greater than or less than that particular value that you're looking for. So again, make sure that this distinction, this difference between equation solutions and inequality solutions are in your notebook before moving on. Okay, so there are three basic steps to testing solutions to inequalities. They're a lot like the three steps to testing solutions to equations. As always, you're going to replace the variable with the given value. You're going to solve the math problem using your order of operations, and then you're going to test it to see if it creates a true statement. If it's a true statement, like left side equals right side, or left side and right side create a true statement, then it's a solution. If it creates a false statement, then it's not a solution. So again, make sure you have those steps written down so that you can solve the problems later. All right, and when we are graphing equations, you have one answer. So let's say the solution was x equals 3. We would just create a number line and we would put a closed dot right where 3 would be. A closed dot means that it's equal to. So in this graph, we see that the solution is equal to the answer 3. We're going to use that same concept when we're talking about graphing inequality answers. So just like with equations, the closed dot also means equal to. But when we talk about inequalities, there's something such as greater than or equal to, and also less than or equal to. So that equal to part in both of these inequalities are very important. They give us that line underneath our inequality symbol. So this is x is greater than, because remember we're reading from left to right and we see the bigger side first, greater than or equal to. This is x is less than or equal to 3. So again, closed dot means equal to. So if we wanted to show all the numbers that are greater than or equal to 3, all the numbers to the right of 3 are greater than, right? Because we have 4, we have 5, we have 6, all those numbers. And that arrow shows that it goes on forever. And then we are coloring all this in to show that even those decimals and fractions in between those whole numbers will also work. And we are topping it off with a closed dot to show, yes, also include 3 because it says x is greater than or equal to 3. So we're including the number 3. Here it's the opposite. X is less than or equal to 3. So we have the closed dot on 3 because we said we want to include 3, equal to 3. and all the numbers to the left of 3 are going to be less than 3. So we're shading those in as well, including the arrow to show that it goes on forever. So everything that's shaded in is less than or equal to 3. All these numbers, including the ones we don't even see on the number line, are shaded in because they are less than 3. And we're also closing that dot at 3 to show that these are less than or equal to 3. Now, when we don't have the or equal to part, the line on the bottom, that just means we're using an open dot because we're telling our audience, do not include this number. So for instance, here we have x is greater than 3. So we want to include all the numbers that are greater than 3. So again, we're going to shade in all the numbers to the right of 3, even the ones in between the whole numbers, because you can have like 3.1, right? So we want to make sure all those are shaded in, including the arrow to show even the ones that we don't see should be shaded in. But we are keeping this dot open at 3 because it says greater than 3. 3 is not greater than itself, so we can't include 3 itself. 3 is equal to itself. This one doesn't have an equal sign, so we don't include 3. We keep it open. Same thing here. This is x is less than 3. 3 is not included because 3 is not less than itself. It is equal to itself, but we don't have an equal sign here. So we have to keep that dot open, and we're just shading in the numbers that are less than 3, which are the ones to the left, and also including that arrow to show that it goes on forever. Very important that you shade in the arrow as well. Okay, so again, closed dot means that you're including the number. You should have an equal sign in order to have a closed dot. And then the open dot means you're not including that number. It doesn't have an equal sign. We don't include the number in that answer. Be sure that you put this in your notebook before we move on to some examples. All right, so first type of question that we're going to go over is testing solutions, which we first talked about. You'll have questions such as this one, which asks which of the x values are solutions to the following inequality. Choose all the answers that apply. So we want to choose all of them that create a true statement. So you're going to follow the 3 steps that we went over previously. Pause the video and try it on your own first. All right, so remember the first step is to take that given value and replace it in your problem. So this is x is less than 100. Instead of x, we're going to put 54. So now we have 54 is less than 100. There's no order of operations being done here because it's just 54 is less than 100. Is 54 less than 100? Yes, that's a true statement. 54 is less than 100. So we can select A. Let's try B. Instead of x, we're putting in 89. So we have 89 is less than 100. Is 89 less than 100? Yes, that's a true statement. And C, if we replace x with 108, is 108 less than 100? No, it is not. It is greater than 100. So the only ones that should work are A and B to create true statements. And that's correct. So again, we're replacing with the value, working on order of operations if we can, and then checking to see if it's a true statement. Go ahead and pause the video and try this one on your own first. All right, so as before, we are replacing our variable with our given value. So instead of 17 is greater than x, I'm putting 7. For the next one, instead of 17 is greater than x, I'm putting 17 is greater than 12. And for the last one, instead of 17 is greater than x, I'm putting 17. So I'm just going to go down the list. Is 17 greater than 7? Yes, 17 is bigger than 7. Is 17 greater than 12? Yes, it's greater than 12. 17 is bigger than 12. Is 17 greater than 17? Is a number greater than itself? No. It's equal to itself, but it's not greater than itself. It can't be bigger than itself. It can only be equal to itself. So again, the only choices are A and B. Okay? So the other problems will just be like that, except sometimes you'll have a problem where you have to replace it, replace both. And so for this problem that says which of the x values are solutions to both of the inequalities. So it has to satisfy both of them. It has to create true statements for both of them. This one has to work and this one has to work in order for you to choose it. Okay? Let's move on now to graphing basic inequalities. So this is where we have to pay attention to the closed dot, the open dot, and then the direction that it's shaded. So we'll do this one together. It says choose the graph of the inequality -3 is greater than x. So this is what we have to choose. Now, if you don't like that x is in the back, you can always flip it. But be careful if you're going to flip it, if you're going to put x on the right, instead of the right-hand side on the left-hand side, and then -3 on the opposite side as well, this one also has to flip. So everybody's going to flip, okay? So again, instead of -3 on the left-hand side, we're putting on the right-hand side. Instead of x on the right-hand side, we're putting on the left-hand side. Instead of this greater than sign, we're going to put this less than sign. Okay, so everything's going to flip. That's only if you, it makes more sense this way. I personally like my variable first, so I can think about my mystery number first. Okay, so we're looking for a number that's less than -3. Okay, so I notice that there's no equal sign. Okay, so it's just less than. So do I include -3 when I'm just talking about a number less than 3? No. So you're not going to include -3. So does that mean it's an open circle or a closed circle? Well, if we're not including -3, we want to have an open circle because we want to tell our audience that we're going to skip over -3. Okay, if we included -3, then we would shade it in. Okay, so I'm looking for a closed circle, or sorry, an open circle. Well, all of them are open circles, so that didn't help me eliminate anything. And then back to the problem, x is less than -3. So I'm looking for numbers that are less than -3. Remember, the further right we get, the greater we get. The further left we get, the less we get. Okay, so I'm looking for shading. It says less than on the left-hand side. So it's either C or D. Okay, so open circle on -3. Oh, that's D. Only D has an open circle on -3 because it's not including -3. It's less than -3. And it has the number shaded to the left. So you should have gotten D for that answer. Okay? The other one had +3 shaded in. That's not what the problem is asking us. It's -3. All right, go ahead and pause the video and try this one on your own. So now they're showing us a graph, an inequality graph, and we need to figure out the answer for it, the inequality sentence. So I notice that there's an open circle, so it's not including 3. I also know there's a 3. Okay, so 3 needs to be in my equation, and then x needs to be in my equation. So this number right here tells us the number, and we'll always have a variable there. This is not including 3, so we know there's not going to be an equal sign. Okay, it's just going to be a greater than or less than sign. It's to the left, so it's less than. So we're looking at all numbers that are less than 3, but not including 3. If it had a closed circle, that would mean it would be less than or equal to 3. But that is not the case. It is an open circle. So you should have put down x is less than 3. Okay, so again, if it has an open circle, it's going to be missing that equal sign. If it has a closed circle, it's going to have that equal sign. It's going to include everybody. Okay? Let me know if you have any questions as you work on these problems, and I'll see you in class.